Okay, so we're going to go through the notes for 4.2, which is multiplying polynomials. In the daily review, it's really important that you understand exponent rules. So when you multiply variables and you're going to add the exponents together. For example, if we have 3x to the fifth, and we're multiplying that by 2x, you multiply the coefficients, and you would have 6, and then you add your exponents. Remember, this is an exponent of 1. So we would end up with 6x to the 6th power when we multiply those together. So make sure you complete the daily review. And again, this is 4.2, multiplying polynomials. So we'll get right into the examples with example 1. So we want to find each product. If we're multiplying a monomial by a polynomial, we're just using the distributive property. So we have 4y squared times y squared, which is going to give us 4y to the fourth. And then we have 4y squared times 3, which is going to give us 12y squared. And that's going to be your final answer. You cannot combine these because these exponents don't match. 4 and 2, if they are both y to the fourth or y to the second, we could combine our like terms. But we can't do anything with that, so 4y to the fourth plus 12y squared is our final answer. Sometimes you'll have multiple variables, but again, same thing, we have a monomial times a trinomial. So we need to distribute fg to every term in our second quantity. So fg times f to the fourth, remember these each have an exponent of 1. So this is going to be f to the fifth g. And then the next one we would have 2 f to the fourth g squared. So this is a 1 also. And then we have minus 3 f to the third g to the third. And then, remember again, this is an exponent of 1, so we would have f to the second g to the fourth. So same idea when you are multiplying with multiple variables. You just kind of keep them separate, and then you'll end up with your final simplified answer. Okay, so make sure that you do A and B for the example 1 practice questions. Okay, example 2 is a little bit because we don't have a monomial now. We have a binomial in this case that we're multiplying by a trinomial. And in the second one, in B, we have a trinomial times a trinomial. So really you have two options with this. Number one, you can think about it as distributing everything through. Or you can use boxes, kind of like the same idea with if we had like x plus 2 times x minus 3. So we could use a 2 by 2 box in order to multiply those together. So we have two terms, so we would need to make a 2 by 2 box. So if you're taking the SATs, they're not going to give you these boxes for the setup. You would need to know how to make them by yourself. So option 1, distribute everything through. So it doesn't matter where you start. Let's start with the closest one. Why not? So we have negative 3 times 2, which is negative 6. Negative 3 times negative 5a, which would be positive 15a. And negative 3 times a squared. So minus 3a squared. And then we also have to distribute a through. So a times 2 would be 2a. And then a times negative 5 would be negative 5a squared. And then a times a squared is going to give us a to the third. So then it kind of becomes like the addition and subtraction problems, addition problems technically, where we're going to combine our like terms. So we have an a to the third. There's nothing to combine that with. So our final answer is going to start with a to the third. And next highest exponent is going to be a squared. We have a negative 5a squared and a negative 3a squared, which would be minus 8a squared. Next highest exponent would be a to the first power, so 15 and 2 is going to be 17a. And then last but not least, we have this negative 6 over here. So we have a to the third minus a squared, 8a squared, plus 17a minus 6. And that's going to be your final answer. So that's option 1 for multiplying, where you just distribute everything through. Option 2 kind of keeps it a little bit more organized, so if you consistently get these questions incorrect, I would definitely suggest using a box to keep everything organized. So we're going to put a minus 3 on the side for the binomial, and then we would have 2 minus 5a, and then a squared for our trinomial. So you multiply to get what goes inside of the box, and then you combine your like terms at the end. So 2 times a is going to give us 2a. And then negative 5a times a is negative 5a squared. And then a times a squared is going to be a to the third. Negative 3 times 2 is negative 6. Negative 3 times negative 5, positive 15a. And then we have minus 3a squared. So if our terms are written in standard form, the nice thing about the box is that there's kind of patterns where you can figure out where your like terms are. So again, start with our highest exponent and we get a to the third. If we look at this next diagonal over here, we have negative 5a squared and negative 3a squared, which would be minus 8a squared. And then this next diagonal over here, we have 17a. And then last but not least, we have our constant, which is negative 6. And again, you can see that both of these are exactly the same answer. And you can use either method that you like. So this and this are exactly the same. Again, either method, pick one, stick with it, and use it. I'm only going to use the box method for the next one just because there's going to be a lot of arrows with the whole distributing through. And again, the box just kind of keeps this one organized. So with this one, it doesn't matter where we put our trinomials. I'll put the first one on the top. So y squared minus 7y and then 5. And then we have y squared and we have minus 1y and then minus 3. Again, multiplication's commutative, so it does not matter where you put your terms. And then we multiply to get what goes inside and then add to combine our like terms afterwards. So y squared times y squared is y to the fourth. This would be negative 7y to the third. This would give us 5y squared when we multiply. The next one we would have minus y to the third. A negative times a negative is going to give us a positive 7y squared. And then negative y times 5 would be minus 5y. And then we have a minus 3y squared, a positive 21y, and then negative 3 times 5 is going to be negative 15. And again, combine our like terms to come up with our final answer. So highest exponent is y to the fourth. Nothing to combine that with. Look at the next diagonal, we have y to the third, so we have a negative 1 and a negative 7, which would be a negative 8. Y to the third. Then we have our y squared diagonal, so 7 and 5 is 12 minus 3 would give us 9. Y squared. 21 minus 5 is going to give us 16y. And then again, last but not least, we're down to our constant, so minus 15 then at the end. And there's our simplified polynomial when we multiply those two trinomials together. Y squared minus 8y to the third plus 9y squared plus 16y minus 15. Okay, so do the example 2 practice questions. Again, if you're going to just distribute, then you don't need to use the boxes. But the boxes, again, kind of keep everything nice and organized and neat. And it's probably a better way to make sure that you're more accurate, but totally up to you which method you use. These types of questions you will often see as trick questions on the SATs. They'll give you multiple choice answers, and one of the answers will be a to the third plus 8b to the third. And the majority of people, I would say, get that wrong. It is not true. So you're confusing that with, let's say we have 3a squared to the second power. Or we'll raise it to the third power, doesn't make a difference. So notice these are multiplied together, which is why you would just square or cube everything. So we'd have 27a to the sixth. This plus sign in the middle makes an enormous difference because of the order of operations. So these are long processes. If you see quantities raised to a power, especially greater than 3, you got a lot of work to do ahead of you. It's not just going to be a to the third plus 8b to the third. If we think about what this actually means, we have a plus 2b. If that quantity is repeated 3 times, it's going to give us a plus 2b, and then we have to multiply it by itself again. So again, remember, multiplication is commutative. Doesn't matter which order we start with. But we can multiply these together. So I'll use a combination of methods with this. So with this, we can FOIL. The first times the first gives us a squared. And then we have a times 2b, so that's 2ab. It helps if you write them in alphabetical order so that you know which terms you can combine. So we have plus 2ab. And then our last term, so 2 times 2 is 4. And then b times b is b squared. But we can still simplify that before we multiply again. And it's going to make it a little bit easier if we simplify it first, because we'll have one whole term that we have less to multiply through. So 2ab plus 2ab is going to give us 4ab. And then we have to multiply this by a plus 2b. So again, you can distribute if you want to. Or we can set up a box just to kind of keep everything nice and organized in order to complete this problem. So we need a 3x2 box. It doesn't really matter which way you set it up. Our trinomial, we have a squared, 4ab, and 4b squared. And then our binomial is just a plus 2b. So we multiply to get what goes inside. A times a squared is a to the third. 4ab times a is going to be 4a squared b. This is going to be 4ab squared. Then we would have 2a squared b. And then 8ab squared. And then 2 times 4 is 8. B times b squared is going to give us b to the third. And again, we can combine our like terms. So highest exponent is on our a term is a to the third. And then if we look again, nicely organized along this diagonal, we have a to the same power, b to the same power, a squared b. So we can add our coefficients. And 4 plus 2 is going to give us 6. A squared b. Notice this stays, the exponents stay the same, you just combine the coefficients. And then 4 plus 8 is going to give us 12ab squared. And then last but not least, we have our b term and nothing to combine that with, so we have plus 8b to the third. And that's going to be your final answer. So notice, it is absolutely not, it's way more complicated than just simply a to the third plus 8b to the third. That's a part of it, but you're missing this whole middle stuff right here. if you don't take the time to multiply it out together to come up with the correct answer. So B, you would think you have the 4th power, so we're going to have to do another step in there, but we can kind of shortcut using the commutative property of multiplication. So again, what this means is x plus 4 times x plus 4 times x plus 4 times x plus 4. So the long way would be to multiply x plus 4 times x plus 4, and the product of that you'd multiply by x plus 4, and then the product of that you would multiply again. But if we break this into 2 pairs, I guess technically this would be the associative property of multiplication, then we can come up with the same thing from multiplying each of those together and multiply it by itself. So if we multiply x plus 4 times x plus 4, that's going to give us x squared. X times 4 is going to give us 4x. 4 times x is another 4x. And then 4 times 4 is going to give us 16. So this product, if we combine our like terms, is going to be x squared plus 8x plus 16. And again, the nice thing is this is going to be exactly the same product. If we multiply these together, x plus 4 times x plus 4, again we would get x squared plus 8x plus 16. So now we have a trinomial times a trinomial, so we can make a little 3x3 box. Or again, you can distribute if you want to. I'm going to make that a little bit bigger. So we have x squared, 8x, and 16, and the reason why I did that is because our numbers are going to get kind of big. X squared, 8x, and 16. This is going to give us x to the 4th, 8x to the 3rd, and then 16x squared. And that's going to give us another 8x to the 3rd, and then 8 times 8 is 64x squared. And then we have to multiply 16 times 8, which is 128x. And then 16x squared. And 16 times 8 again is going to give us 128x. And 16 times 16, which is going to be 256. And again, we're combining our like terms. So our highest exponent is 4. So we have x to the 4th power. And then we have our x to the 3rd powers. So 8 plus 8 is 16. X to the 3rd. And then we have essentially 32 plus 64, which is going to be 96. X squared's 128 plus 128 is going to be 256 x's, and then plus 256. And there is your final answer. Again, it's not even close to simply x to the 4th plus 256. In this case, we have all these middle terms that, again, would be missing if we didn't multiply those correctly. So make sure that you do example 3 practice where you're finding the product and you're raising it to the 3rd power, in this case, not to the 4th. Okay, so that's all the required stuff. There's just a shortcut way using a formula in order to do example 3, and that's using Pascal's triangle. So Blaise Pascal is a famous mathematician, and he kind of figured this out, and it's actually really helpful for powers that are greater than 3, let's say, so you don't spend all kind of time doing something. It's a faster way to do so. So this is Pascal's triangle over here. I'm going to highlight it in purple. And the way that you come up with Pascal's triangle, you notice you have the ones all along the outside at each row. So you always have a 1 on the next row. And then you add the two numbers above it to get this number here. So in this case, 1 plus 1 is going to give us 2. And then for our next row, we have 2 plus 1 is 3. 2 plus 1 is 3. And then we have our 1s on the outside. And then next row, 3 plus 1 is 4. 3 plus 3 is 6. 3 plus 1 is 4. And then we have our 1s on the outside. And then next row, we could keep going on forever and ever and ever. But we'll just do a couple more. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. And 4 plus 1 is 5. And then again, we have our 1s on the outside. So one last little example then. We'll have our 1s on the outside. So if we're looking for the next row, if we're looking for a plus b to the 6th power, 1 plus 5 is 6. 10 plus 5 is 15. 10 plus 10 is 20. 10 plus 5 is 15. And then 5 plus 1 is 6. So that's going to give us our coefficients for our next row using Pascal's triangle. Okay, so you can actually use this then to expand any binomial in the form a plus b to the n, where n is a whole number. So example 4 kind of shows you that. Because we're raising this to the 3rd power, we need to look at the what we would get for a plus b to the 3rd. And the coefficients here are 1 and 3 and 1. So that's why these are written here, 1, 3, 1. And you can see our coefficients 1, 3, 3, and 1. So you start with your first term, which is k, and you raise that to the highest power. So notice we're going to have k to the highest power, which is k to the 3rd power. And then we're going to drop down 1 degree each time for k. So there's k to the 2nd power, k to the 1st power, and k to the 0 power. So again, look at these exponents for k, 3, 2, 1, 0. And then we have to take our next term. The sign goes with it, which makes it a little bit tricky also, which is -5. So we're starting at the lowest power, which is 0. So you can see this, we have -5 to the 0 power, and we're increasing each time. So we have -5 to the 1st, -5 to the 2nd, and -5 to the 3rd power. And then we just simplify this expression, and it's going to give us our binomial expansion of k minus 5. So anything to the 0 power is 1. So we just have 1k to the 3rd from our first term, which is simply k to the 3rd. And then in our next group, this is k squared. And we have to multiply that by 3 and by -5. So we would have minus 15 k to the 2nd. And then in our next group, this is 3. This is simply k. -5 squared, -5 times -5 is positive 25. So we'd have plus 3 times 25. If you have 3/4, that's 75 cents. So 75k. And then again, k to the 0 is just 1. So we have 1 times -5 to the 3rd, which is -125. Which would just be -125. So you save yourself a lot of foiling and using the box by using Pascal's triangle to expand this trinomial, or this binomial, which is k minus 5. And again, you can kind of see the same thing is going on. This one we're raising to the 3rd power. So our coefficients are 1, 3, 3, and 1. 1, 3, 3, and 1, but our expressions are a little bit more difficult in this case. So our variable term is 6m, and we start with 6m to the 3rd power, and then 6m to the 2nd power, and then 6m to the 1st power, and 6m to the 0 power. So start with the highest exponent and drop down 1 each time. And then we have -8, and we're going to raise that to the 0 power. So we start with the lowest, which is 0, and go all the way up to 3. So then -8 to the 1st power, negative 8 to the second power, and negative 8 to the third power. And then we just have to simplify these expressions, and that will give us our polynomial for 6m minus 8 to the third power. So 1 is just 1. 6m to the third is 6m times 6m times 6m, which would be 216m to the third. Anything to the 0 power is just 1. So our first term, 216m to the third. And then we have 3. 6m squared is going to be 36, the quantity 6m squared. So square the 6, square the m. And then we'd have to multiply that by negative 8. So 36 times 8 would be minus 288 m to the second. And then this is 3. 6m to the first power is just 6m. Whoops, wait. 36 times 8 times, 36 times 8 times 3. I forgot about our coefficient. That should be 864. 864 m to the second. And then 8 squared is going to be 64. So 64 times 6 times 3 is going to be 1,152 m. And then we're going to have, this is just 1. So we have 1 times negative 8 to the third, which is 512. So minus negative 512. So we'd have minus 512. And again, there's our simplified trinomial. So if using Pascal's triangle is confusing to you, then don't use it. Just take the time to multiply 6m minus 8 times 6m minus 8 times another 6m minus 8. So it's a longer process. It's going to take more time, but if it helps you to get there, then by all means use that if it's way less confusing than using Pascal's triangle to help you expand correctly, especially also if you are not getting the correct answers when you use Pascal's triangle, then stick to just multiplying using boxes and or FOIL. And as always, let me know if you have any questions.